Learning AI automation, especially when you're diving into a tool like n8n, it can feel just incredibly overwhelming.
Oh, absolutely. It's the sheer volume, right? You walk into this giant digital hardware store and you're surrounded by hundreds of nodes, connectors, all these specialty
And
tools.
every aisle is unmarked. Everything looks useful, but you have no idea where to even start.
You end up spending weeks just researching the tools instead of actually building the systems.
That's the friction point for every serious learner. You want to create these intelligent, persistent systems, but you get completely stuck in the catalog. Our goal today is to just cut through all that noise.
Yeah, with precision. I mean, we've built
Right.
literally hundreds of these production workflows. And what we found is a core truth. You don't need 100 tools. You only need a foundational set of 10.
10. 10 specific n8n nodes that, if you master them, cover something like 80% of all practical, real-world AI automation you will ever need to build. These are the absolute essentials.
hmm So our mission in this deep dive is to unpack these 10 core tools. We're going to move through it logically, mirroring how a workflow actually runs.
Okay, so where do we start?
First, how we get data into the system. Second, how we teach the robot to think and connect. And finally, how we manage the flow so the system doesn't just collapse on itself.
Let's start at the beginning then. The foundation. Getting data in and getting it ready.
All right, segment 1. It's all about the first 4 critical nodes. They establish the start point, the input source, and the necessary cleanup process.
Okay, so the first question has to be, how does the system even know when to run? That brings us to our first 2 nodes, the triggers. Number 1 is the schedule trigger.
We call it the alarm clock.
The alarm clock, I like that.
It's the proactive element. You set a specific fixed interval for the workflow to activate, daily at 6 a.m., hourly, maybe every Monday morning. You use this when the robot needs to do work while you're completely offline.
That's the perfect tool for persistent monitoring. I can program an AI workflow to check, say, the top 5 financial news sites every morning at 6 a.m., summarize the key points, and have that summary sitting in my inbox before I even wake up.
Precisely. The system is working proactively on a schedule that you dictate. Now, if the schedule trigger is proactive, node 2, the event trigger, is purely reactive. This is the doorbell.
Meaning it doesn't run on a schedule.
Not at all. It just sits in the background, silent, consuming almost no resources. It only activates, it only rings when an external event happens.
Like a new email landing in Gmail or a Slack message with a key phrase.
Exactly. Or a form submission on your website.
So mastering these 2 is really about changing your mindset from manually checking things to setting up passive, immediate reactions. You stop hitting refresh on your screens.
That's the key shift. Now, once data is flowing, we need a place to read from and write to. That brings us to node 3, Google Sheets. We call it the digital notebook.
Sheets is just ubiquitous. Everyone has access. Everyone kind of knows how to use it.
And that's exactly why it's foundational. Your automation needs a simple, free, easily accessible place to store or retrieve data. Maybe your workflow needs to read a list of 500 leads from a sheet or write a summarized report back into a new row.
I get the accessibility, but let me push back a little here.
Mhm.
Why are we relying on a spreadsheet for potentially mission-critical data? I mean, isn't that inviting problems down the line compared to, say, a real database?
That's a great question. And yes, for true enterprise scale, you move to dedicated databases. But for that 80% of automations you build first, Google Sheets is a visual, non-scary database. It's free, it requires 0 setup beyond logging in, and you can visually check the data.
So it's the right tool for the beginning stage.
It's the perfect accessible database until your workflow really demands more complexity. It just minimizes the friction to get started.
Fair enough. Now we get to node 4, which sounds crucial for stability. The edit fields node. This used to be the set node, right?
Yeah, and we call it the label maker. This node is absolutely the Swiss Army knife of data cleanup. And, I'll be honest, I still wrestle with messy data input.
Oh, me too.
Sometimes the raw data coming from a trigger is just chaotic, weirdly formatted timestamps, inconsistent names. You have to admit, managing input data is often the hardest part.
I agree completely. We've all spent hours debugging a workflow only to find out a key field was labeled customer mail V2 in one place and email address in another.
Exactly. This node lets you take that messy pile of data and impose order. You can rename fields, changing that awful first name 123 to just name. You can remove junk data you don't need, and you can set the data type correctly.
So if a later node, especially a picky AI API, expects a field called query and my input is labeled user prompt, the whole thing just stops.
It breaks every time. The edit fields node is the guarantor of consistent labeling. It prevents the robot from getting confused. It ensures stability.
So how important is that clean labeling, really, for these AI processes?
It's everything. That consistency is what prevents the system from breaking down the line.
Right. So with clean data in hand, we can pivot to segment 2, logic and connections. These nodes teach the robot how to think and how to talk to the world outside n8n.
Now we start with decision making. Node 5, the IF node. You call this the fork in the road.
It's the simplest form of branching logic. It asks a single binary question. Is this condition true or is it false? And based on that yes or no answer, the data goes down one of two paths.
Can you give us a practical scenario for that?
Sure. A new lead comes from a website form. The IF node asks, is the email from a top-tier client domain? If yes, path A, it immediately texts your sales manager. If no, path B, it just saves the lead to Google Sheets for later.
I love that. It moves the automation from a simple straight line into being truly context-aware. It prioritizes actions.
It does. But sometimes two paths aren't enough. What if you need to decide between 5 different actions? That brings us to node 6, the switch node, or the roundabout.
So instead of a simple two-junction, it's a traffic circle with multiple exits. Exactly. The switch node handles multiple possible paths based on a single piece of input. Imagine you're processing uploaded files. The switch node checks the file type. Exit 1 routes PDFs to an OCR agent. Exit 2 sends images to be resized. Exit 3 handles text files.
That makes complex workflows so much cleaner. I mean, chaining 10 IF nodes together would be a visual nightmare.
It would. This keeps the whole diagram readable, which is half the battle when you have to maintain it later.
Okay, now we get to the powerhouse. Node 7, the HTTP request node. You call this the universal translator. And this feels like the most powerful concept to grasp.
It might sound technical, HTTP request, but understanding this node is the key to future-proofing your automation skills indefinitely.
Explain that power simply for us.
This node lets n8n communicate with any software anywhere on the planet that have an API.
And an API is just a defined, structured way for two different computers or apps to talk to each other securely.
That's all it is. And because pretty much every modern web service uses an API, this node guarantees a connection. Even if a brand new AI service launches next week and there's no dedicated button for it, you can still connect on day one with this node.
That is massive. So let's use the example from the source accessing a tool like Perplexity's API, pretending there isn't a dedicated node. How does this node manage that secure connection with, like, an API key?
Right, so you use the HTTP node, you paste in the API's URL, and you set the method, usually PUPO or GET. For security, you define your credentials using the generic credential type. And crucially, you use header auth for the API key.
What's header auth?
Think of it like a secret, invisible handshake that happens before the real conversation starts. It keeps your sensitive key hidden from the main request.
I see. Security is built into the channel itself.
Then you define the body of the request using JSON. This is where you actually ask your question. You're composing the prompt, the parameters, everything right there inside the node.
So I'm defining the entire complex instruction set for an external AI service, sending it securely, and getting the structured response back.
Exactly. You could be getting a complex report from a brand new AI or just a random joke from some tiny API. The process is identical.
Whoa. I mean, imagine scaling that, connecting to 1 billion potential tools we don't even know exist yet. That ability to talk to the unknown is kind of breathtaking.
It future-proofs you completely. Knowing this node means your skills won't expire when the next big thing launches.
So what really makes the HTTP node the ultimate future-proofing skill?
It lets you connect to any API immediately without waiting for a pre-built connector.
Okay, so we've established how to get data in, clean it, make decisions, and connect to the entire internet. Our final segment, nodes 8 through 10, is about structure and flow, making workflows scalable and stable.
Right, starting with node 8, sub-workflows. We call these the helper robots. This is all about modularity.
It reminds me of building a house. You don't build the whole thing yourself. You hire specialists, a plumber for plumbing, an electrician for wiring.
That is the perfect analogy. A sub-workflow is a separate, smaller automation that does one specific, reusable job. Maybe it's a dedicated AI summarizer agent. Your main workflow just calls this specialist when it needs it.
The power is in reusability, right? You build it once.
Immense reusability. Let's say a request comes in from a Telegram chat. The main workflow intercepts it and then calls the sub-workflow. The sub-workflow does all the complex research, maybe using that HTTP node we just talked about, and then sends the clean final result back to the main workflow to deliver.
So you never have to rebuild that research tool logic again. You just plug it into any future automation. That must speed things up a lot.
It moves you from building these giant, hard-to-maintain flows to just assembling reusable Lego blocks of logic.
Next up is node 9, the loop over items node, or the one by one. This one solves a really common and expensive mistake: rate limiting.
This is absolutely critical. If your automation gets a list of, say, 100 customer emails that need processing, you might be tempted to fire all 100 requests to an external service like OpenAI at the same time.
And what happens when I send 100 requests in 1 millisecond?
The external service, whether it's ChatGPT or any other API, sees a sudden, massive spike in load. They think it's a denial of service attack, and they immediately block you or crash the connection. That's rate limiting.
So this node acts as a safety valve.
Exactly. It forces sequential processing. The loop over items node takes that big list and processes it one item at a time. By setting the batch size to 1, it ensures every item is treated correctly without overwhelming the system. It slows things down on purpose for the sake of survival.
That measured pacing sounds like the difference between a system that runs reliably for a year and one that crashes on its first big test.
Precisely. And finally, node 10 is split out. We call this the bag of marbles node.
That analogy instantly clicks. You have one bag with lots of individual items, and you need to separate them.
That's the function. It takes a single list of data, a big clump, and separates it into individual, distinct pieces of data.
But why is that separation necessary if the data is already flowing?
Because most nodes that come after it work best, and sometimes only on single items. If you send a raw list of 10 email addresses to a standard Gmail node, it gets confused. It might try to put all 10 addresses into the to field of one email instead of sending 10 separate emails.
Ah, I see. So the split out node makes sure every node gets one single, clearly defined item to work on. It prevents data confusion.
It eliminates that confusion entirely. It's the final structural cleanup before processing.
It's amazing how often the stability of a complex system comes down to making sure a single clump of data doesn't overwhelm the machine.
We just mapped out the first 10 foundational nodes you need. Honestly, the structure you now have is incredibly robust.
Let's do a quick recap. You can trigger automations proactively with the schedule trigger or reactively with the event trigger. You can store and clean data easily with Google Sheets in the Edit Fields node.
You can introduce smart decision-making using IF and switch nodes to handle complexity. And the true game changer, the HTTP request node, lets you connect to literally anything on the internet today and everything that launches tomorrow.
And you control the flow, making it stable, using sub-workflows, ensuring smooth processing with loop over items, and eliminating data confusion with split out.
If you focus only on mastering these 10 tools, you fundamentally shift your whole approach. You move away from agonizing over which tool to pick, and you focus entirely on the outcome you want to create.
It changes the conversation. And that leads to our final provocative thought for you to think about. We've covered the essentials of automation, the predictable logical movement of data.
Yeah, you've built the highway and the traffic system. But what separates this powerful automation from true intelligence? What happens when the system needs to self-correct or adjust its own plan or reason about things?
That is the essential pivot. We've given the system rules, but now we have to put a driver behind the wheel. That's the next level of complexity. True AI agents, dynamic code, high-level aggregation. That's where the real complexity and the real magic begins.